Hi. In this video, we are going to discuss what the Verilog code for D flip-flop and its simulation. So here we have given the module name DFF for a D flip-flop module, and there are two outputs are there, and one is an output Q, other one is output QB, that's Q bar. Since the Q is going to be the target signal inside the always block, it has to be declared as a rich data type. So output rich Q we are defined. And since the Q cannot be updated immediately, so we are going to use this, we are going to define the QB statement as an continuous assignment statement. So we will have it outside the always block. And also we have two inputs, a D and a clock over here. And now here, if you look into it, then the always block, this always block is controlled by the sensitivity list. So the sensitivity list here is the passage of the clock. So the positive edge of the clock, the Q will follow the D. Whatever the Q value is there, whatever the D value is there, that will be given to the Q. And also the concurrently we have whenever the Q value is changed, immediately the QB value will be computed here. So this flip-flop is compiled, and now we are going to simulate the flip-flop. So flip-flop we are going to simulate now. So here we have the objects. So select all the values in the objects, all the signals in the objects, then select them, add wave new. And now I just to rearrange for my convenience the inputs on the top and outputs at the bottom. So that will be easy for me to do. Now for a D, I give a clock of 100 and let it be in a rising edge. And for a clock, I'm giving the value, a clock value of 25 and let it also be in a rising edge. So as we run this, we will be able to see the performance of the D flip-flop here. So now here, when I click here, we will be able to see the corresponding value over here, but it's a edge triggering. So what instead of moving it manually, what we will do, we can use this icon, that is find the next rising edge. So that will take us to the every rising edge of the clock. Only to the rising edge of the clock it will take. So now let's say this is the rising edge of the clock. Then the D is 1, so output is set to 1. And to the next rising edge, when it moves, the D is 1, so till output is also remain to 1, Q bar is going to be 0. And for a next rising edge, the D is changed to 0 and Q is also changed to 0, then QB is set to 1. So this cycle continues since we have the repeated same kind of repetition of D signals, and also we have a clock of the same period. So that's about the D flip-flop. Thank you.